Hello, welcome to the video series for solving systems graphically, where we're going to use um, graphs to solve systems of equations. The first thing we're going to do is look at identifying the graphs of systems of equations. Um, so the directions say for each linear equation below, classify them as consistent dependent, consistent independent, or inconsistent. So the first thing we need to identify is what these types are. So let's first look at what lines we have here. In line 1, it says we have y equals 1/3 x plus 3. So here is the 1/3 x plus 3. And for line 2, here is 1/3 x. Notice that they have the same slope. Well, since they have the same slope and different intercepts, they're never going to intersect. So this has no solution. And a solution is where the lines cross. So that would be a solution here. So this has no solution, and this is actually going to be inconsistent. So for inconsistent, let's note that the lines are parallel. So they're parallel lines, and they have no solution. This is for an inconsistent system of equations. Let's look at the next lines. Here I have y equals negative 2x plus 7, and here I have y equals negative x plus 5. So I have two different slopes, two different intercepts. So here this will be line 1, and here's line 2, and they have one unique solution. And so we're going to mark that it's a unique solution, and we're going to put that point. That point is negative 2, 3. So we would click the button and we'd type negative 2, comma 3. Lastly, I've got y equals, excuse me, we're not done yet. The last thing we need to look at is what type of graph it is. Well, it's not inconsistent because it has a unique solution. This one's actually going to be consistent independent. It has at least one solution, but everything about them are independent of each other. So let's mark consistent, independent. Has one solution, and they're called unique. So we'll say one unique solution. The lines intersect. Which means they have different slopes and different intercepts. Let's look at the last line, y equals negative 3/2 x. And here we have y equals 3x plus 2y equals 0. So we want to solve this. So we'll go over here. We'll say 3x plus 2y equals 0. Subtract 3x, and we'll get 2y equals negative 3x. Divide by 2y, or divide both by sides by 2, and we get y equals negative 3/2 x. So we have the same lines. Well, by process of elimination, this one is going to be consistent dependent. And that means that the lines are going to be the exact same. So when that happens, we have infinitely many solutions. So for consistent dependent, identical lines infinitely many solutions. Okay, let's go look at another example real quick. The same example, different problems. It says we need to make sure we classify them by consistent, dependent, independent, or inconsistent, then answer the questions about the solutions. Well, here I have negative 2x plus 5 in the first box, and I have 1 half x minus 5. I've got one unique solution, which indicates to me what type of problem it is, what type of graph. So one unique solution means that it's consistent, independent. That means that it has one unique solution, and my solution was going to be 4, negative 1. Line 2, I have negative 1/3 x and x plus 3y equals 0. I could solve if I wanted to, but notice that I have one line. I have one line here. That means that they are consistent dependent. They're identical equations. When they're consistent dependent, please remember that it's infinitely many solutions. And lastly, I've got two lines, and they're parallel. They're the exact same slope. This is going to be an inconsistent solution. And think of inconsistent as there's nothing consistent about it, so that there are no solutions. Alright, that's it. Just remember to look for your solution types first, then choose the proper system, and then choose the proper solutions.